Michelle Leroux. Welcome, everyone. Michelle is a climate scientist at the National Oceanic and Atmospheric Administration, where she leads the El Nino forecasting team. Michelle can clarify exactly what her title is in a bit. We chatted about 2 months ago about the current conditions and what to expect in the tropical Pacific, where El Nino and La Nina happen. But this year we're waiting for El Nino. We are on El Nino. So we're going to talk about these things in a minute. We know everyone is anxious to know what's going on with El Nino, with this summer of climate madness. What happens to El Nino is the wild card, right? So we're here with Michelle. Welcome, Michelle.
Thanks, Pedro. Thanks for organizing this.
I have a few questions for Michelle, and we are at the point that we have to define whether we are on an El Nino or not. So my first question to Michelle is, are we on an El Nino, and how we define it, how we officially state it's an El Nino?
Right. So that's a loaded question, right? Because as we know, as climate scientists, that El Niño-Southern Oscillation is this incredibly sprawling, complex, multivariate, multi-time scale phenomenon. And so everyone looks at El Nino a little differently. So we issued an El Nino watch in April of this year. And then last month in June, we said we were in El Nino. Every agency around the world does this a little differently. In fact, if you were to look at the discussions by Ecuador and Peru, they said that El Nino, arrived in like March or April, because they're focused on sea surface temperatures near the coast. And more recently, the WMO weighed in, and they're a collective consensus of the National Meteorological and Hydrological Services. They also agreed that we're in El Nino conditions. There are still some agencies, though, who say we're not quite there yet. And part of that is because they have stronger thresholds. So they want to see more signal. They want to see more forcing. Whereas we have a different set of thresholds for our purposes. So the other tricky aspect of all this is we're talking about a climate phenomenon, which means that this isn't like a weather forecast where day to day the weather changes and you can describe it perfectly. Climate is the average of weather. So we have to describe an average while we're living this day to day. So that can be tricky because that means we need to know something about a whole span of time. And NOAA, for better or worse, decides to update monthly. However, El Nino is technically seasonal in our books. So our official definition, and I'll go ahead and show that right now. Let's do this real quick. Is this table. A lot of people recognize this. It's on CPC website. They like this because they can go in and pick out the past El Nino episodes, which are red, and then the La Nina, which are blue. And this is just showing since 2010. The table on the website goes back to 1950. And so basically, when we have 5 consecutive 3-month overlapping seasons, we call that an El Nino, as historical El Nino. But when we're updating month to month, we're not going to know whether it's actually going to verify, right? I mean, we're not going to wait. We're not going to wait until 5 consecutive seasons is over and then be like, hey, by the way, everyone, there was an El Nino. Because people would laugh at us, and they should. So we have to have a way to do this in real time, month to month. And that does take some risk in account. Let me show you what I mean. So when we updated last month in June, we decided that we had what's called El Nino conditions, meaning that conditions were very much consistent with El Nino. And if they continue and last for that duration of time, which is the climate time scale, then it will be considered a historic El Nino episode. So the three things in the team, so this is 11-person team that sits down and we go through this flow chart. Everyone makes their own decision. And the first question we ask is the Niño 3.4 region, is that greater than 0.5 degrees centigrade? Last month it was, in both of our data sets, OISST and ERSST were at 0.5 degrees C in May. So in early June, when we were updating, we had the May monthly average, and those that hit 0.5. And then the other question, and this is a forecast question, right? So it's not enough for it to be warm for just a month or two. It's got to persist. And so we have to have a forecast, which could be wrong, but we have to have a forecast that is going to persist. And then the last thing that we asked ourselves is, what does the atmosphere look like? And so when all three of these things qualify, then we say El Nino conditions have arrived. But there's some risk here. It may fall apart, which is why the atmospheric coupling and the ocean coupling is important, because that's what will help, keep this event going.
So,
all right.
Yeah. So there's these three conditions that need to be met to call an El Nino. How many of these are currently being met? Could you tell us more? Especially the one I'm interested to talk about is the last one, is the atmosphere, right? Usually El Nino events are triggered by atmospheric fluctuations. Sometimes this year, but then the ocean responds and warms up, and then we need to see the atmosphere responding again. And this is how this positive feedback loop that helps an El Nino event grow is established. So how do you decide on the atmosphere? Which data sets and which observations help you determine that?
Yeah, so the ocean looks good. I mean, so we have Niño 3 values right now for the past month of June. ERSST data says 0.8 degrees centigrade. In the OISST data set, it is 0.9 degrees centigrade for the monthly average of June. So that is clearly in excess of our 0.5 thresholds. And if you look at the sea surface temperature departure maps over the Pacific, they're clearly quite warm. So there's no debate at all with respect to the ocean. So what Pedro is saying is, what about the atmosphere? Because it's the atmosphere that for many global impacts needs to be punched, for lack of a better word, or else you won't get these ripple effects upon the rest of the globe. So there's a couple of things we look at for this. And when we talk about atmosphere conditions, we're talking about a lot of different items, for lack of a better word. We're looking at cloudiness, we're looking at rainfall, we're looking at winds, both at low levels and upper levels. There's even this variable called velocity potential that we look at. Basically, we're looking for overlapping pieces of evidence. We don't want just one indicator showing something. We want to see a preponderance of evidence in support of El Nino. The other thing is atmospheric indices are really noisy. And by noisy, I mean that they fluctuate a lot from month to month. And what Pedro is alluding to is that the Southern Oscillation Index, which is a very popular measure of the atmosphere, actually returned to more near average values this past month, which kind of caught some people off guard. They said, whoa, what happened to El Nino?
But that's the official Southern Oscillation, right?
Right. Well, so I have a slide for that. Let me get to that.
Because
I know I've got a lot of slides. So
I like to
talk
follow
about the SOI.
Okay, perfect. You can explain it.
Yeah, so I got a map. So a lot of these graphics, if you see a really nice graphic, is from our ENSO blog on climate.gov. So credit to the climate.gov team for creating these. So the traditional Southern Oscillation Index is the difference in pressure between, it's supposed to measure between the Eastern and the Western Pacific, because when you get these differences in pressure, that means you are getting changes in the overturning circulations and the changes in rainfall and convection that we want to see with El Nino. It's that change in the overlying circulation that ultimately can have knock-on effects to the globe. So it is important to know what that overturning circulation is doing. And so the traditional index is station-based. It's literally this dot over Tahiti, and another station here in Darwin. And it's a difference in sea level pressure between those. And the reason it's those stations is because back in the day, we didn't have a lot of data over the tropical Pacific. And so we just needed to find some stations that were close enough to the tropical equatorial Pacific that would measure those pressure differences. Nowadays, and at CPC, we use something called the Equatorial Southern Oscillation Index, and it's the same variable, sea level pressure, but it's for these big regions, one over Indonesia, one over in Eastern Pacific, and it's the difference in anomalies between those. So it mimics the Tahiti minus Darwin traditional Southern Oscillation Index. This index for the month of June was actually minus 0.5 standard deviations below average. What that translates into is that it was very much consistent with El Nino conditions. The other index was near zero. All right, so it did not have much of a difference. But I'd argue maybe that's because that it's noisier, it's station-based, it's off the equator. We tend to, when these two indices are head-to-head, tend to rely a little bit more on that Equatorial Southern Oscillation Index. For June, the value was actually in the bottom quartile. So it was the bottom 25% of all June values. So that was a pretty good value for us. And so we're fairly convinced that we are still seeing coupling, but it's weak. It's not particularly strong. Especially given the sea surface temperature anomalies, I would expect stronger values, and we're not quite seeing that. But it's possible that's because it's just it's a noisier index, and maybe next month we'll see it bounce a little harder. Anyway,
could there be anything related to the pattern of warming of this El Nino event that has somewhat it started on the eastern side of the equatorial, on the far eastern equatorial Pacific, and those warm anomalies have crept into the west, which is not what we traditionally think. I mean, this is what people thought maybe before we joined this field, how people thought El Nino events grew from the east to the west. And then after the big El Nino events of the 80s and 90s, we somewhat started thinking of events being triggered from the west and propagating in the opposite direction. But this event is it's almost like we're back to the 60s and could that be the cause that why the atmosphere is not seen, because the temperature gradients that drive the atmosphere on this region where the atmosphere is sensitive haven't changed much? Have you thought about these? Have you heard someone thinking about these?
Yeah, so what Pedro is alluding to is that we all in grad school read these papers by maybe we should call them out, Rasmussen and Carpenter, 1983. Yeah. And we were all like told this is how El Nino evolves. And then every other El Nino since then has not evolved in that way. And so I think one lesson there is that it was a very limited data set, because they were writing that paper at a time when they only had like 6 El Ninos or something like that. And so that was a very small set to draw from. And what we've learned since then is that El Ninos can be very variable and they can look very different from each other. So I think that's good. And on some level, it's why we still have jobs, because we have to understand this thing and where it's headed. And if it's always changing, then that keeps us on our toes. So this event is really quite interesting because it did start, and you can kind of see this. It stretches back really to March and April, but the earliest timestamp here is early May. But you can see the idea here, which is that we saw strong positive anomalies. This is where temperatures are warmer over this region near Ecuador and Peru. And then gradually over time, what you'll see is that the warmest waters, or these anomalies, are expanding to the west. So this is our most recent update, and you can see now that this 1 degree C isotherm is now extending out almost to the date line. So this has been slowly expanding to the west. The other interesting thing here is that for a lot of this period, particularly early on, we saw warm conditions in the Western Pacific here. And it's only more recently, you know, I mean, it's less warm, but there's still a lot of warmth north of Australia. This isn't a great sign for us El Nino scientists. We like to see temperature differences. So typically it would be cooler here. We might even see some below average blue shading through this region. And we're not seeing that really to a large extent at this point, which is somewhat unusual. So I did do this. I did a composite because people were asking how is this evolution relevant to other El Niños. I know everyone on this call is going to be like, "Oh my God, what are you showing us?"
No, this is exactly the goal for everyone out there. This is exactly what we want to do here in this channel. We like to nerd out.
Yeah, this is a real nerd fest. Yeah. So this is a Hofmahler diagram. We love it because it shows over time how the tropical Pacific is evolving. And so this is this year through June. So this is the most recent data point. And all these red colors are those above average sea surface temperatures that we were discussing with those maps. And you can think of this as the Eastern Pacific, and over here is the Western Pacific, closer to Indonesia. So this is showing a span of the entire equator across the tropical Pacific. And what it shows, and then on the y-axis here is time. All right, so these numbers correspond to months. I got a little lazy, so, you know, but 3 is March, 4 is April, 5 is May, and so on. So it's showing the evolution over time. It starts in the far Eastern Pacific. You start seeing that amplitude, and then we see that expansion to the west here in this Hofmahler diagram. And so that's how this one is evolved. And that's very similar to the typical El Nino evolution during the 60s and 70s. And so I've composited that on the right panel. Now, this is an average of a bunch of El Ninos together. So it tends to be lower amplitude than what you see in the event-to-event space. But here you can see that the timing is such that, I mean, not so much the timing, but the position of the anomalies started with the largest amplitude in the Eastern Pacific and then expanded to the west. And that's very different from, say, the events that we saw during the 80s and 90s. So here is 80s and 90s. This is the plot I was just showing you in the 60s, 70s. And you can see here is more west-east. And we saw that even a little bit more, but with less amplitude at the maximum during the 2010s. So this sort of configuration we haven't seen in a long time, and it seems to be what we're seeing here. Now, there's a rub here. So you can't just go back to the 60s and 70s El Niños and be like, here's our analogs. This is how this event will evolve. Because the nuance is that we're seeing a lot of warmth in the Western Pacific, and that's unusual. And Pedro has done some research recently looking at a little bit of this, which is that we tend to see trends that are very strong in the Western Pacific. And that's new to us. It seems like the strongest climate change signal and the trend since like 1980 is the Western Pacific. So we're seeing two things. We're seeing like old style 60s, 70s retro El Nino, plus this new thing, which is the above average temperatures in the Western Pacific.
Maybe super far ahead of where I was thinking of going, and where in the 60s and the 70s, wasn't the mean climate also very much like the current state, in which we call it like La Nina-like, with a stronger walk? When was the last time that on average, for a long period of time, the Pacific had this state in which the Western Pacific is anomalously warm for a persistent multi-decadal period. Wasn't it that time too?
Yeah, if you look at that big chart, and I'll go ahead and pull
You
it
have
up,
that?
that big chart of doom, but it is kind of useful. It's horrible to look at, but people use it, so it must have some traction. So if you look at this is 1950, and again, La Niñas are in blue, El Niños are in red, and you can track all the historical El Niños and La Niñas going back to 1950. And so this period, really, especially since 2010 or so, we've had a lot of blues. So a lot of more La Nina-like states here. And I think Pedro is right. So the only other time that we saw a preponderance of blues like that was in the 60s, 70s period. Now, not as much, I don't think.
Yeah, it's not.
Although some of these neutral periods were slightly on the cool side, so they were negative. They're just not La Nina negative. So I think you're right. There is something to that about the mean state being a little bit more like it is now. But that Western Pacific warmth, that's still very different from
the Western Pacific has been really warm for a long time, and again, maybe just to round up this point is that for the atmosphere to respond to an underlying El Nino event in the SSTs, we refer the word El Nino, La Nina just for the oceanic part of this global phenomenon, the oceanic part in the equatorial Pacific. So for the atmosphere to start responding, we need contrasts along the equator. And if the Western Pacific is warm, it's difficult for an emerging El Nino event to create those gradients and the atmosphere to respond and then feedback and make it grow explosively. How we are taught that El Nino events should grow through unstable growth during this time of the year, particularly we're in that window when the ocean and the atmosphere are most interactive supposedly in the equatorial Pacific. Yet it's not super clear that's going on. We're probably only 2 months into that period of intense coupling. We still have a few more months, but not a lot. That coupling window closes before the peak of El Nino events. So by September, depending on who you talk to, that window.
Or which model you consult.
Yeah, or depending, exactly. But we have a question on the chat. I was paying attention to the chat, and Saul Osman is asking, what about the other basins? Could the other basins be, what's the state, and could they be conspiring to slow down this event? If we think it's being slowed down, I think it's not growing extremely fast.
It's an oceanic conspiracy. So this is really an excellent point. So one thing I want to share these maps. This was actually put on our ENSO blog this morning, and I really found it very striking. Emily Becker and climate.gov team put this in here. So it's a comparison of sea surface temperature anomalies now, June 2023 here, and to be clear, we are not predicting necessarily a 97, 98 scale mega event. We're putting our probabilities about 1 in 5 chance of a really large event, but it's still worth going back and looking at this more canonical June 1997 anomaly. What's interesting is that, at this point in June, it was actually very similar to a current event. That is, the sea surface temperatures off Ecuador and Peru were quite strong, rivaling this current event. So when you look at the tropics, at least the central and eastern Pacific, it looks pretty similar. But the rest of the global ocean is very different. And so this is giving us some concern, because we don't know exactly what El Niños do in this very, very warm climate. There's some hints but a lot of it is research and is exploratory. So just incidentally, a couple of years ago, I started working with Gert-Jan van Oldenburg, who's in Netherlands. He passed a year ago, but he had this idea of Harry Hindon at the Bureau of Meteorology in Australia to start looking at what's called relative sea surface temperatures. And essentially it's taking that ENSO region, Niño 3.4, and then what it does is it subtracts off the tropical mean sea surface temperature average. And it gets more at this question of gradients that are important to the growth of El Nino. And so we went ahead and we implemented this into operations as CPC. It's running in the background. Our official measure is still the classic Niño 3.4 with a 30-year departure removed. But it's really interesting. Here, I'll show you. Okay, so this is the Niño 3.4. I know, nerd out. Time to nerd. There should be like some kind of like alarm that goes off.
This is for everyone out there. This is in the weeds.
Yeah. Well, based on the last call, there's some people who really want this. So, this is for you. So this is one way to show the growth of El Nino. It's showing the Niño 3.4 index, our standard mechanism, the one that we show on the website with that big table. This is monthly data. The black line is the current evolution. The y-axis showing the intensity of the Niño 3.4 values. And usually when you're over 0.5, that's what we consider it an El Nino event. Now I'm showing past years here. So remember, we had all those past El Ninos from 1950, and each of those is a different line here. All right, so these were all classified as El Ninos based on that big table. And as you can see, El Ninos tend to grow through the summer, and then they maximize in the winter. I also put some color coding based on the intensity of the event. And you can see the current one is kind of it's in that strong El Nino grouping, at least so far. What's interesting is the relative index. Hang on, where did I put it? Is there. Okay, looks a little different, right? So before we saw it like up here around 0.8. Relative index is like 0.45. It's just kind of moseying along, meaning that in a relative sense, Niño 3.4 isn't as warm as it is compared to the tropical mean oceanic state, which is super warm. So speculation alert, we suspect that the atmospheric response is better mapped to this relative index right now than the standard Niño 3.4. Another translation to that is that it's possible Niño 3.4 has some added warmth that is climate change, and it's not necessarily these coupled ocean atmosphere processes that make up El Nino. This is all speculation. There will be researchers who email me afterwards and they're like, how dare you say that? Or what do you mean by that? Can you quantify that?
But I think it's important to talk about this, trying to be serious, because we've seen this issue of defining this anomaly relative to a changing background and what's the best index to define an El Nino or La Niña event come up several times or several events now. And I think probably everyone in the community would agree that the current indices are not great in a changing climate. And
yeah,
I was wondering if we could brainstorm, maybe I could do it too, is what would be the mechanism for all of us to agree on better, newer ENSO indices? I mean, we could talk for an hour about this, but I wonder, this is something I had the same problem in one of my research papers, that the model had
this is getting to be a problem.
Warming, and I created a relative Niño 3.4 index almost in the same way that you did in your paper too, just to work around this issue of background warming. should we have a workshop? Should we? This is a paper.
I'm going to do a little
was,
self-promotion.
No, I think it's an
So-
important. I think it's an important issue, and
Yeah. Yeah, it is. So more recently, I think it was August, the Bureau of Meteorology Australia reached out and they said, we need to talk about this changing climate issue in our ENSO indices and what to do about it. Because also the Bureau of Meteorology was using, because the WMO, they recommend this 30-year base period. So for folks at home, if you have a 30-year base period that's really old, like say 1960 to 1990, it's going to be cooler than your current base period. And we were like, this makes no sense. Like, say you live in a La Nina in 1950s, sometime in the 1950s. Why would you compare the anomalies relative to a base period that occurred 70 years later? You know, that's a warmer state. So why are we doing this? So we need a better way at understanding climatologies and where the warmth is relative to this changing climate. So that Gert Jan van Oldenburg and Harry Hinden production has led to this effort, which is with the operational and research side of Bureau of Meteorology in Australia. This is great because NOAA and BOM we don't agree on everything, but we're starting to agree on this.
okay, awesome.
And so this was submitted last week, first round of review.
Okay.
And I'm happy to, if anyone's curious about this paper, to send it along, but it's still an open question because the reason we banded together, NOAA and Bureau of Meteorology Australia, on this effort is because we kind of want to put it out to the research community and say, hey guys, what do you think of this? And so that's why there's a paper, another one that looks at this a little bit more exhaustively. And hopefully at some point we do get some energy behind this, and I would be really eager to have everyone's thoughts on that.
Yeah, for the research community, maybe it's not such big issue because we can always look at the full length of a record and see what's the trend and try to remove it. Sometimes a linear trend will not do it, and we do something fancier, and in that way we can get rid of those background changes that
Yeah
and overprint an individual El Niño event. It's still the challenge even for the forecasting community, because the models have these tendencies to create these climates in the Pacific. I mean, this is a kind of worms. Maybe we should. Yeah,
no, we definitely need to get our hands around this. So one of the reasons linear trend fits are not totally favored by us is because we don't know where the endpoint is, and it would probably need constant readjustment. You would have to extrapolate it. It gets really messy really fast. So that's why, yeah. So that's one reason. But anyway, I feel like we're in the weeds, so we should move on. What other questions do you have?
Yeah, but still, I think it's important for everyone to keep in mind that, well, looking at an El Nino happening on top of background changes in the climate of
and
the
it could be getting worse. It could be like accelerating now. Yeah.
And this is an actual research question. Is something we haven't figured out for multiple reasons, mainly because we don't have great models to study climate changes in the tropical Pacific yet, but they're coming. That's my
they're coming. That's optimistic. Yeah, so some of our climate models, let's put it out there, still have the same biases that we saw during the first generation of climate models. But cold tongue biases, convection biases. So yeah, there's a lot to throw at this problem. We haven't made a whole lot or made up a whole lot of ground there.
Maybe we should think and share with everyone watching us, what are our thoughts of what's going to happen, given that we're not seeing this really strong coupling? How do we weight all these forecasts forecasts, the dynamical forecasts, which don't have climate change on top of them, or they do, but we don't, it's not entirely clear how it works, and that are predicting and the evolution of El Nino. And what do we expect by the end of this year, which is when El Nino happens, right? Let's recall
Right.
That's
I'll
the
go
name of
ahead
El
and share
Nino.
my
It happens
screen.
around Christmas.
Okay, so this is our official forecast. I laugh only because it's just a bunch of really large numbers. We're very confident that this El Nino, we're in an El Nino, and we're pretty confident it's going to continue. In fact, the question I'm getting about this plot is, why isn't it 100? Like, you're in it, so why isn't it? And that's a good question. And the reason it's not 100 is that, believe it or not, in our historical record, we've seen some big busts. And so there's always this like little pocket of fear. like right now, El Nino's humming along. But if, again, we don't see that coupling between the ocean and atmosphere, things could fall apart really quickly. So there is that little room for error there. But ultimately, the message is that we're very confident this El Nino will continue. The other question that people have, and I apologize for the format of this, it's an ASCII file, it's a text file of numbers. Unfortunately, like 90% of science is just looking at ugly files. So essentially what we're giving here is probabilities in excess of certain amounts in the Nino 3.4 region. So remember, the East Central Tropical Pacific, we're looking at the amplitude of the sea surface temperature anomalies in that region. And so we have different cutoffs. These cutoffs are totally arbitrary. I could make them 0.8 degrees C cutoffs. Here I picked 0.5 because why not? And so the El Nino probabilities, remember, our cutoff is 0.5. So as one might expect, we have these 96% probabilities. So we're pretty confident that El Nino this. Then you can get into the greater than 1 degree C probabilities. And these are pretty large too. So and these are the upcoming seasons. This is November, December, January is roughly usually when El Nino maximizes. And so our larger probabilities are near there. And it's about 80%. So we have an 80% chance of exceeding 1 degree C during that season. And then we have what we informally consider a strong threshold, 1.5. And again, these are very arbitrary, but we think that there's about a 50-50 chance of exceeding that threshold. And then we get into the 97, 98, 2015, 16, the major El Nino event categories, which is usually greater than 2. And so we're around 20% there. So we're saying 1 in 5 chance of that. This is not that different from what we issued in early April. We've been bubbling around. I staggered these two plots because I needed to line up the target period. But when we issued this in early April, we were around 20% in excess here. Obviously, we're a little bit more confident in the El Nino now that we're in it. So these haven't changed that much. And if you look at our model guidance, it hasn't changed a whole lot. And one of the comments that Pedro brought up there is that we're in this new climate. So what do you rely on? And increasingly, I think the climate forecasters tend to rely more on dynamical models than statistical models. That's not to say the statistical models don't have their use. They're very valuable. They actually help us decompose and understand the different predictors and dynamics driving. And so, but they're based on past history. And unfortunately, we're in this new climate. And so dynamical models are initialized with the current ocean state. So that very warm ocean state we saw everywhere, dynamical models see that. Now, whether they do the right thing with it is still an open question, but at least they see it. And so when you look at last month to this month in our forecast plumes, it hasn't changed a whole lot, at least in the North America multi-model ensemble that we're considering. So, and if you look the month prior, not a huge change there too. So this is a fairly stable El Nino forecast. And right now, the ensemble mean maximizes just north of 1.5 degrees C. Just barely, a nudge. And the forecasters largely in agreement with that.
This is important because a lot of the talk about this El Niño event is whether it's going to push global mean temperatures into a new record. Recall that the last record in global mean temperatures in global warming was in 2016 with the strong El Niño of 2015-16. So is this year going to be a repeat or not? Based on this, I would say the chances are not very high to have an event that can push temperatures so high.
So there was
above
an
that
ENSO
threshold of record breaking or 1.5 or 2 degrees temperature anomalies.
So
which doesn't mean that other factors in the world ocean could push it, but
right. So there's an ENSO blog post on this recent one. Karen Gleason and CEI put this together. It was edited by Tom DiLiberto at NOAA, and I like this plot because it shows the global temperature for years entering a strong El Nino. And now keep in mind, we don't know whether this is going to be strong. This is still an open question, but maybe it doesn't need to be, because if you look at this plot, we're already relative to the other actual strong El Ninos where we know they were strong. It is already beating it. And the other thing that Karen points out in this article is that these numbers these lines don't really go down. Like they're pretty much stuck if you look at all of them. So this makes it a little bit more probable that, at least relative to other strong El Ninos, even if it doesn't reach strong intensity, we might beat those out. Now, this isn't showing all years. 2020 is actually in 2016 were equally strong, really. And so it is this number is still below the other years, but it is interesting that we're already seeing amplitude like this, even though we don't know whether this is going to be strong or not. And maybe it doesn't matter.
But so maybe I'll wrap up with my last question, which I think it's important to discuss, is there's so much going on in the climate system this year, almost every year, but it seems like this year is particularly unusual activity in other basins, in the extratropics. So, and this is probably a question for both of us, because it could be important to identify which impacts are we already seeing or we can expect throughout the rest of the years, even if this El Nino maintains moderate amplitude and does not exceed 1 degree, which sounds
right.
What the probabilities are saying is most likely that it might not go over 1 degree, which is still a moderate El Nino event, and it can have impacts throughout the world. What of those impacts will be El Nino, and what else that we're seeing it is not El Nino? How we can distinguish?
Right. Okay. So we've been really focused, like laser focused on, the tropical Pacific itself and how strong that is. And what Pedro's is bringing up here is that what about the impacts across the rest of the world? And also how do those El Nino impacts interact with climate change, which is very prominent. So here, I just want to show you this. This is, sorry, I'm going to show my bias to the contiguous United States here. So this is the Climate Prediction Center puts together these outlooks once a month. This is the outlook coming up for July, August, September. And one thing that should really grab your attention is that it's above average probabilities almost everywhere. This is very similar to the map we issued for June, July, August, which is this classic summer period. If you actually look at El Nino composites going back into the historical record, Brian Brettschneider, who is in Alaska, he's a climate program manager in Alaska. He creates these great plots. And he was using era 5 for these plots, and this is surface temperature data, and he composited all. So when I say composite, I mean averaged all the previous El Nino events during June, July, August. And what you see is this very flat pattern. I mean, there's color here, but this is like the weakest shade. Very weak. If anything, it leans a little on the below average temperature side. So, you know, when reporters have been coming to me about Texas and whether that heat is El Nino, I'm like, I don't see much evidence for that at all. And interestingly, if you look at the last 30 days, so this is just for June, we did see a lot of below average across the United States, obviously with the exception of Texas and Pacific Northwest, but actually it's been on the cooler side. This is just 1 month. Remember, this forecast is for 3 months. So things may be heating up coming up here. Anyway, but the point being is that when we sit down as forecasters and create these maps, we might not be weighting the El Nino signal at all, which is usually very weak over North America. We might just be weighting climate change and trends. And so largely, I would argue that's what this map is about. So going forward, even as the El Nino signals grow into the winter, we're going to have to expect trends, and climate change is going to interact with those signals. As we know, the drier conditions tend to be more amplified in climate change because you've got the hotter temperatures on top of it, which causes a lot of evaporation, dries things out. We also know from work that others have done that rainfall intensity tends to become more intense. So you can have these very typical El Nino impacts. So this is showing different El Nino impacts across the globe for different time periods of time. It's from the International Research Institute for Climate and Society. And we have to realize that on top of that will also be climate change, and we might see intensification of those El Nino anomalies. And we don't need to see a strong El Nino to have that happen.
Yeah, and I agree with you. And we're seeing some things, you know, for everyone. I'm in the Southern Hemisphere right now in Argentina, where I'm from. And we have a big teleconnection down here too, from the equatorial Pacific. And usually, yeah, it's right there. And it starts in June. It's important to look at the systems, right?
I actually looked. I was like, is it there? And no, not yet. Not yet.
And actually, what I was actually going to say is everyone here is waiting for an El Nino because we're just coming out of a 3-year-long drought. You can see some of the remnants in Michel's plot in that brownish part in eastern South America.
So this is June. This is past month, and then this is what you expect with El Nino. And I was just circling here some anomalies I saw in June that seem consistent with El Nino. But Argentina is not one of them.
No, yet, and that's likely to be related to this, the traditional Southern Oscillation Index being neutral, because that is the metric of the global atmospheric response, especially to the Southern Hemisphere. And so even though it's just
interesting,
it was a choice that Walker did to measure. Well, it was his only choice to measure this phenomenon from measurements from those islands. They do capture the Southern Hemisphere expression of the atmospheric responses. And if we don't see that Southern Oscillation, this is the atmospheric part of we don't see it reacting to the SSTs. It means we won't see the impacts in the Southern Hemisphere.
That's a really good point, because remember the Tahiti minus Darwin's off the equator, so it might be better toggled to the Southern Hemisphere.
For the Southern Hemisphere teleconnections, it's a better index.
Interesting. That's really interesting. I did not know that, so thanks.
We thought hard about this problem in our 2013 paper with Amy Clement and Clara Desser about the Southern Oscillation without an ocean, because the mode in the atmosphere, it actually is off equatorial. The atmosphere, the purely atmospheric mode And then when it excites an El Nino, it becomes equatorial.
Yeah.
But this
and
is
this
in the way it's
Yeah. And this gets to this point about how different agencies around the world might prioritize different indices. And like if you're in Argentina, it sounds like you want to prioritize this particular index. So I think that's a nice illustration of that point, is that there's reasons that we would prioritize different aspects of ENSO.
Maybe that's a good message to emphasize that there's all these ways we can measure these phenomena in ways that are meaningful to different places. And the most important one is the fact that El Nino was called initially on the coast of Peru, where we've been having a massive El Nino since February or March.
Right.
And it is not showing signs of receding.
And 2017, we saw similar warming along the coast of Ecuador and Peru. It was very warm in March or April 2017. And in the Central Pacific, in the Niño 3.4 region, it was cool. Like,
yeah.
So NOAA was very much like, well, we're neutral. And then they were like, well, we have an El Nino. And they did. For them, for their purposes, that El Nino was very significant for them. So yeah, there's a lot of ways. I think we have to understand that there's no one magic index for every aspect of El Nino. And we haven't even, Pedro, you and I haven't even talked about flavors. So, it's like, we were just talking about like the basin wide versus coastal. It's a mess.
Yeah, where this event will fall into our spectrum of flavors,
right.
We'll have to see until it reaches peak magnitude. But maybe as a summary, it's as always. This is I think in our shorter careers, this has been a constant. Every El Nino event is different.
Yes.
We haven't seen an El Nino event follow similar behavior. Even the ones that are similar, they still show differences. And this is something we're still studying. And I was not expecting this event to evolve this way.
Yeah. Remember when we last met, our YouTube, which is online apparently, we're sitting here super anxious whether this is even going to become an El Nino. So at least we get that out of the way.
And so this is a reminder for everyone. We're still in a research operational mode. It's not like weather forecasting that you have weather events happening every day, every week. So your science can advance very fast because you're observing these phenomena very frequently. We get a chance to observe this system every few years. And then we all go back.
We have since 1950, 22 events.
And that's all we have to study this phenomenon. Maybe we can use paleoclimate records and we can use climate models. And climate models are getting there in how realistically they simulate El Nino events. And we've seen a lot of progress, but it's still not reality. So this is like weather prediction decades ago. And we are moving slowly because these events also happen.
And we're seeing this change in the climate too. So we're just trying to understand El Nino here, and then on top of it, you've got global warming, and that's going to mean that we're going to see surprises. Every event's different, and we're going to see surprises.
Yeah. So thanks for joining. I think we should.
Yeah, this was fun.
On the hour. Let's see how this event evolves. But I want to invite you to come back in a few months.
Yeah, because it's in a few months we'll be talking about the winter outlook, and people will be really interested in that. But yeah, we'll coordinate on
maybe towards the end of this event in October, or we can meet again. And
we can have an emergency session if it falls apart.
Also, let's do that. But for everyone out there, thanks for joining us.
Thank you. Appreciate this.
It's great to see people on the other side now or in the future when you watch this video, and don't hesitate in reaching out to us if you have any questions. We love to talk.
Apparently, because we went an hour.
All right.